Yes. Hello students. So in the previous class we discussed about what do you mean by a surface chemistry. What do you mean by a surface chemistry? Now today we are going to discuss one of the important part of surface chemistry, that is called as adsorption. Now, before you understand what you mean by an adsorption, let me consider one example. Here I am going to consider a open container. In this I am going to add charcoal. In this I am going to add a charcoal. From the opening side, I am going to allow pressurized chlorine gas to pass into it. Pressurized chlorine gas to pass into this container containing charcoal. As we go on passing the gas in a container containing charcoal, the molecules of gas start settling or going to accumulate on the surface of the charcoal due to the presence of free valencies. When you allow a pressurized gas into a container containing charcoal, the gas molecules start accumulating on the surface of the charcoal. As the process goes on, suddenly, as initially the pressure of the chlorine gas was very high, suddenly it start decreasing. The decrease in the pressure of the gas or accumulation of the gas molecule on the surface, what you are going to call it as adsorption. Now, how to define this adsorption? So, first and the foremost thing that we need to remember is the gas molecules have been accumulated on the surface of the charcoal. So we can say adsorption is a surface phenomenon where accumulation of liquid or gas molecules on the surface of solid, sometimes liquid, is called as adsorption. Adsorption is a surface phenomena where accumulation of the either liquids or gas molecules which are high molecular species on the surface of what? Solid or liquid. Now, two important terminologies we are going to use right here. So the first terminology is the molecules, that is liquid or gas, that are going to accumulate on the surface of the solid, sometimes are liquid, are called as adsorbate. So whichever the liquid or gas molecule that are going to accumulate on the surface of solid or liquid are called as adsorbate, and the material which provides space for accumulation of these molecules, gas or liquid molecules, which is in solid form, that is called as adsorbent. Now, whatever the gas molecule that are going to accumulate on the surface of the charcoal due to the presence of surface area or free valency are adsorbate, and the material that is providing space for these gas or liquid molecules to accumulate on its surface, that is charcoal, is called as what? Adsorbent. Now, how can we define with these two terminologies? Adsorption is a surface phenomena where accumulation of the adsorbate on the surface of the adsorbent is going to take place. This is called as adsorption. This is called as what? Adsorption. Now, next point we need to discuss is desorption. Desorption. Now, let me consider example. So, this is what a charcoal which consists of free valencies, that is empty spaces on the surface. Empty spaces on the surface. Now, if you allow any gas molecule or colored liquid molecule on the surface in a pressurized form by applying pressure, what is going to happen? Due to the presence of these free valencies or empty space, those liquid molecule going to accumulate on the surface of this charcoal, those gas molecule going to accumulate on the surface of this charcoal. So this process, what you are going to call, this process is what you are going to call adsorption. Adsorption. Now, if you start removing these liquid molecule, these gas molecule from the surface of charcoal, that process is what you are going to call desorption. Desorption. Desorption is nothing but removal of the adsorbate from adsorbent. That is what you are going to call desorption. That is what you are going to call a desorption. Now, some important conditions you need to remember right here. Conditions are for adsorption, or on what all condition this adsorption is going to depend on. So the first condition is surface area. Surface area. As I already explained that due to the presence of free valencies on the surface or empty space on the surface, these gas or liquid molecules are going to accumulate on the surface of what? This solid. So as you go on increasing the surface area, the number of free valencies is also going to increase. So as usual, as expected, adsorption is also going to increase. As you go on decreasing the surface area, the number of free valencies or empty space is going to decrease. So adsorption is also going to decrease. Second one, temperature and pressure. Now, just imagine some gas molecules have been accumulated on the surface of this solid. So now, if you are going to start increasing the temperature, what is going to happen? Whatever the gas molecules that have been settled on the or accumulated on the surface of the charcoal start evaporation. They undergo a process called evaporation. Start evaporating. If you are going to decrease the temperature, so the gas molecules or the liquid molecules, whatever accumulated on the surface of the charcoal or a solid, undergo a process called condensation. That is evaporation, they will get evaporated. no gas will be available on the surface. You cannot say it is adsorption. And condensation, again it will become what? On the solid surface, what will be accumulating on the solid surface when it will undergo condensation? Solids only accumulating. Liquid gets solid, gas also get converted into solid. Solid is not adsorption, because as I have already explained right here, what should accumulate on the surface? Liquid or gas. But here, due to condensation, what is accumulating? Solid. So you cannot call it as absorption. For these reasons, temperature always maintain constant. Temperature always maintain constant. Now, when you allow a pressurized gas into a container, then only due to that pressure, the gas molecules start accumulating on the surface of the solid. If you are going to decrease the pressure, accumulation of the gas molecule going to decrease. If you increase, the accumulation of gas molecule going to increase. Now, third one, type of molecules. As we already told you that only gas or liquid molecules can accumulate. So third point is, it also depends. What adsorption also depends on the type of molecule that going to accumulate on the surface of the solid. Clear? Now, next point. Mechanism behind adsorption. Mechanism in adsorption. Let me consider a solid material or a liquid. Just say I am considering a liquid molecule, a liquid solution. Here the liquid molecules, just say these liquid molecules, whatever available on the surface also, all these liquid molecules are surrounded with the same type of molecules. If it is made up of chlorine, if it is of chlorine gas, or if it is some bromine water, not bromine. If it is, for example, if it is, let's say, let me take one example. Just say, if it is a liquid called as A, so here inside a liquid A, what type of molecules will be there? A molecules will be there. They are surrounded with what type of molecule? A only in all direction. Due to the presence of same molecules in the all direction, and it is surrounded with the same type of molecules everywhere, there will be a presence of what type force? A balanced force will be there. Balanced force will be there. See, this is a A molecule, A liquid. Just say I am considering A liquid. So in this, A molecules will be there inside and one on the surface. For example, inside, A molecule is surrounded with the same type of a molecule. That means A is surrounded with A only in all directions. So there will be a balanced force. But whereas on the surface, A molecules are present, but at some places A molecules are surrounded with A molecules, but at the surface A molecules are surrounded with the B type of gas molecules. Gas. On the surface, only few A's will be available, few A molecules will be available. At bottom, they are surrounded with A type of molecule only. But at the surface, A molecules are surrounded with the B molecules. So there you are going to observe, there at the surface you are going to observe unbalanced residual force. Unbalanced or residual force. Now what is going to happen? As A is surrounded with A type of a molecule inside, so it has got attraction force. So because of this attraction force, whatever the A molecule that are present on the surface, as attraction force is passing on to each molecule, so the A molecule that are present on the surface, they start attracting these molecules towards itself. They start attracting these molecules towards itself. Now, what is going to happen? This is a condition on the surface. This is a condition on the surface. Now, as it starts attracting the gas molecules from the surface, the gas molecules start coming and settling in between these A molecules. In between these molecules. How it will be possible? Breaking and rearrangement. Breaking and rearrangement. So first what has to take place? The bond between A and A, the bond between A and A molecule need to break. Electrons will, free radicals will generate, and at that place rearrangement will be possible with which one? With B, with the molecule of B. But due to the breaking up of the bond and rearrangement, a type of energy is going to release. A type of energy is going to release, that is called, that's why it is called as exothermic reaction. Exothermic reaction. A type of heat energy will be released during this process, that's why it is called as exothermic reaction. And this whole rearrangement and breaking and rearrangement is taking place on the surface due to the presence of unbalanced residual force to make it as a balance. That's why adsorption is going to take place only on the surface. And during this breaking and rearrangement, some type of heat energy is releasing, that is called delta H. For that reason, the reaction adsorption is called as exothermic reaction. Exothermic reaction. Okay, so remaining concept we will study in the next class. Thank you.